On today's show, HVAC design with Mr. Drew Cameron. Today we have a special segment from Drew Cameron. We launch our brand new course titled HVAC Design Principles this month, and as usual, we like to give out a little taste of the content. So if you are a member, make sure to assign this to your team members, and if you're not a member, then sign up for a free 30-day trial to get access today. If you are watching this on Facebook, click the link below to sign up for the trial. Now let's dive in today's content.
So let's take a look at a duct system, right? And so we have an upflow configuration here, and if this thing were laying sideways, that would be a horizontal, and if the ductwork were in the bottom of the machine, that would be a downflow system for the most part, generally speaking. But in the pink or the red, as you see it on the screen, we have our supply duct, right? We have the plenum, which is the box on top of the furnace or the air handler right there in the center of the picture, and then we have the main duct, main supply duct, or what a lot of people call a trunk. I don't like to call things, like I say, that people don't know, but they understand main supply duct. And then we have the branch ducts that feed each of the rooms. And each of those then have a takeoff as well as a register boot. And then there's probably a register within the living space itself that you don't see in the picture here, right? And so the one item that you see kind of going on here and going up the wall is basically a run out or a branch or a supply run out that goes out and then goes up into a stack or stack head that goes up to a register in a sidewall on the second floor, or this could be a high sidewall on the first floor, depending on how this house were laid out. But this is typically how you see a duct system laid out, generally speaking, within a house. This is kind of like the skeleton, if you will, of what a duct system looks like. Now, again, you may get into a situation where you have a system in an attic, and it might be a lot of flex. Now, what I can tell you is flex was never intended to be a primary duct. It's designed to be a secondary duct. And so if you see main flex supplies as flex, I'm not saying that people didn't do it and that you can't inherit it and use it. I'm just saying I don't recommend it, and it's not a best practice. It would be recommended to put in a duct system that is sheet metal and wrapped in insulation. I'd rather get rid of any insulation that's on the inside of the duct so people aren't breathing fiberglass. I can use then branches, flex branches coming off that can run no more than 15 feet to get to my supply register, because that's the best practice as well. Running flex no more than 15 feet. And so you'll see a lot of this content, like I said, in the additional educational resources I'm going to provide to you. So flex, not designed to be a main, always designed to be a secondary duct, not a primary duct. And again, flex has basically a shelf life of about 10 to 15 years. Odds are, if you're inheriting flex, it's also probably out of code, meaning it probably has an R2 or an R4 insulation value to it, and code today is now R8. So again, I'm not saying that you can't use it. Again, it's probably just not in the customer's best interest. And so you might think about renovating or replacing that entire duct system, or anything that you can at least touch and access without opening up walls and ceilings and floors. And then in the blue, we have what is known as the return. And now the return, in most areas of the country, we can do what is called free return. And so what you see here is we have a duct that comes off the bottom of the unit where the fan is in this unit, and we tap into the return. Some people call this the drop in the boot. And then you have your main return duct. Some people call that the return trunk. And then you have a return branch, which is tied to the outside to bring fresh air in. You won't see that everywhere in the country, but in areas like Colorado, Chicago, and a few others in the country, that is code, and you have to bring fresh air in. And the idea there is that we're pressurizing the house by bringing that fresh air in, and we're bringing it in before the filter and whatnot. That way we're controlling it, we're filtering it and purifying it, humidifying it, heating, cooling it, whatever we got to do. But we're putting a positive pressure in the house by bringing in that outside air. But what we'll see in a lot of houses here is what we call this free return here. They cut a hole in the top of the duct, and the duct is mounted tight to the joist in the basement, in this particular case, and then they nail sheet metal across the bottom of the joist there, as you can see. As you can see here, there's the panning here in the joist bay, on the bottom of the joist bay, and then there's a cap right here, and then there would be a cap at this other end, and then there would be a hole cut in the floor, and then we would use the stud cavity between two pieces of drywall as, again, a chase or a channel, and then we would cut a hole in the drywall, and we would put a return grill on the wall, and we use the joist space and the stud spaces and stud cavities, if you will, of the building structure to be duct conduits, air conduits. And so you can do that in most municipalities. There are some municipalities around the country where you can't do that, and you'll find that everything has to be ducted. In attics, everything tends to be ducted, right? But in basements and in crawl spaces, sometimes that's not the case. And you may see a configuration like this. Otherwise, you'll see everything is hard piped. But that's in essence the general concept of laying out a duct system, if you will. So let's talk about some bad practices and some things that you can where you'll see, some issues. I'm not saying that you have to get rid of these, but if you're having performance issues and comfort issues and high utility bills and other things that the customer may complain to you about, and it would indicate to you that there's a lack of airflow. Putting in a bigger system is not always the answer. Again, if you have a 5-gallon bucket and you have 10 gallons of fluid, and you want to put 10 gallons of fluid into a 5-gallon bucket, how much is going into the 5-gallon bucket? 5 gallons, right? No matter how badly I want 10 gallons to go in there, it's not going in there. And so if I keep pouring it, it's just going to overflow. In essence, that's what happens with ductwork, but it just kind of backs up. It's like cars on a highway, and they just kind of get stuck in traffic. And now things just kind of start to create chaos and turbulence within inside the ductwork. And so what you see here is a rectangular shaped ductwork. Like I said, not the best. The air is traveling cyclonically, and so as it tries to make this turn here, as you kind of see how the air wants to go, what's happening here is you have a dead spot in the heel of this elbow here. And then you also have a dead spot right here on the inside heel of the elbow. And this air can't make the turn as easily as it could. So something to do better would be to kind of do something like this, right? Round the outside radius, but you still have this inside heel, and look at the problem it's creating. So again, by going with round and sweeping the elbow, okay, if you will, on the inside and the outside radius, you minimize that dead spot. And so I do apologize. These are images out of a textbook, and so they're not the clearest. As you can see, they're older textbooks, but you get the idea. And so when you go out into a space and you see things like this out there, okay, could you offer an option to the customer, especially if they're having comfort issues and performance issues as far as utility bills and not being comfortable in certain spots of the house, and maybe it's noisy, because again, these types of things will create noise, right? This creates turbulence, which creates noise. And so could we basically prescribe some solutions where we renovate or replace the duct system? And as again, you can kind of see the different throats, squared versus radius, and again, ideally it would be a radius in here too. So again, look for what you're seeing out there. What can you upgrade? What can you replace? Right? So here's another duct system. Ideally, you also want to allow at least 24 inches between duct takeoffs and at the end of a duct run. Okay, definitely no less than 12, meaning the main ductwork has to pressurize. Okay, if this doesn't pressurize, then these won't pressurize adequately. And so as you can see here, we like to have 12 inches between fittings, as well as the end of the ductwork, right, between each of the supply branches here. And even if they're on the other side of each other, it wouldn't make sense to have these directly across from each other. I mean, it would make better sense to have these directly across from each other like this, because now they're getting the equal pressure, equal velocity, and so the equilibrium is going to be established to allow these guys to get enough air coming out of them. And again, we're 24 inches off of the main duct itself here too, with this main elbow. And you can see in here we have turning vanes. They're little louvers inside the ductwork to help the air make that turn. But we've also 12-inch offset between ones on other sides from each other, on the other side from each other as well. So again, staggering things appropriately is important. Now again, I get it. You might be inheriting a duct system. But if they're basically talking about comfort problems, maybe what you might find is that somebody just hooked up ductwork and connected it and ran it to where they needed to run it to in order to accomplish the objective. And task completion, check the box. But see, if you get out there and they talk about comfort issues, you can't say that just putting in high efficiency, advanced technology equipment with a variable speed fan is going to solve all the problems. It's not. A bad duct system is a bad duct system. And as you can see here, also, as we peel off, 4 supplies, then we shrink down, so we maintain the velocity, right? Because air has left, the volume of air is less, and so with less volume of air, in order to maintain that static pressure, that friction, and that velocity, so these, supplies get air pushing out of them, not just kind of dribbling out of them. We shrink the ductwork for the amount of air that's now left, because let's assume we pulled out, maybe we had 1,200 cubic feet of air going in here on a 3-ton machine. We have 100 going out here, 100 going out here, 100 going out here, and let's say 200 going out here, right? So that's 100, 200, 300, 500 came out of this ductwork, right? So I shrink this down, so this ductwork carries 700, and then each of these gets what's left, right? And so, again, that's the principles behind designing ductwork, right? So this recipe for disaster in many cases, right? And too much traffic going on here and going to create all kinds of problems. You've got to kind of spread out the distribution. I get it, in many cases you've got a tight space, but you've got to get creative. You don't just go ahead and check a box and say, I put in ductwork and I connected runs and I ran runs and supplies to rooms. That's not what you're supposed to do. Unfortunately, you're going to inherit a lot of jobs out there, because that's what happened in new construction. The cheap company got the job because they were able to check the box that they sold heating and air conditioning, they installed it, and it was able to run. The builder didn't know any better. It's not their job to know that, and it doesn't matter that it passes inspection. Inspection is that you can pass code if in fact it did pass inspection and get code on a permit, right? But code is the least that you can do. Code doesn't mean that it works. Code just means that, some inspector said it was safe. Doesn't mean that it is, right? And so here are some pictures of some of the types of things that you're going to see out there. The snake of the flex, running all over the place, not supported properly, pinched off in some cases right here. Extra flex running all around, like I told you. Right on the box on the manufacturer, it says, don't install flex any longer than 15 feet. But you're going to see that that's what's happening here. And then you're going to see disconnected and broken ducts and things like that. You're going to find all kinds of stuff out there, and you'll be able to add to this library of horrors, if you will. Right? The other thing you have to take into consideration is flex, like I said, the slinky. Think in terms of a slinky. When you compress it, you compress the ribbing on the inside, that wire membrane that's on the inside, wire plastic membrane on the inside. And so a fully stretched 10-foot duct, if we had 10 feet of duct, if we compressed it just 4%, would come down to 9.6 feet. But that 4% compression would reduce the amount of air and would require you to increase by 1 size, right? So let's assume this was a 7-inch duct or an 8-inch duct. If I compress it just a little bit, I have to take that thing up to a 9-inch duct, and then a 10, and then an 11. And in many cases, there isn't an 11-inch duct. Very rarely will you find 9-inch. So more often than not, you're probably going to go from 8 to 10 here, right? And then from 10 to 12, here as well as here. Because at 30% compression, you're choking off the airflow and the performance of that duct. So you can't just say, I sized the duct for the airflow if you don't connect the flex properly. So again, that's more of an installation thing for your install team. But when you're inheriting a duct system, you have to assess that and take that into consideration and make sure you're either replacing the ductwork, okay, or instructing your installers to fix the ductwork. Because otherwise, again, high efficiency advanced technology equipment hooked up to a low efficiency duct system, the customer is not going to get what they're paying for. You're just going to waste, you're going to help the customer waste energy more efficiently, and they're not going to be comfortable because it's just not going to perform. In fact, a lot of people seem to think that a variable speed fan is a remedy or a panacea for all poor airflow situations. It's not. It actually can exacerbate and make things even worse, make them noisier, make them less comfortable, and again, shorten the life of that machine.
Hi, I'm Daryl Yashinsky.
Hey, I'm Bob Larkin.
Many of our contractors meet with us monthly, and you, chances are, have met with us monthly. We found that members have deeper and greater needs.
So we came up with next level coaching, which is we meet a lot more often, and there is accountability to deal with some of the issues of money, growth, finding employees, having an exit strategy to get off this roller coaster. These are the issues that contractors want answers to, and we can provide those answers in Next Level Coaching.
When you join Next Level Coaching, you're going to find solutions that are easy to implement and logical. Most importantly, we hold you accountable to specifics. We're going to meet twice a month and have specific to-dos. And with those specific to-dos, we're going to discuss and dive into your financials in a very granular way. You're going to have a clear budget. We'll be able to establish pricing. We're going to help you create leadership programs that build your people. We're going to help you find people. You may think of differing ways to engage employees that will keep them more involved by joining Next Level Coaching.
So if you're interested in making more money, growing your company, finding good employees, and developing an exit strategy, give Dale and I a call. We'd be happy to talk to you about Next Level Coaching.
And we're going to see you on the next level.
The last thing you have to take into consideration is what we call duct design and redesign. So you're inheriting a duct system, and so you've got to go ahead and you go through some redesign principles and practices. Now, in the folder of additional educational resources that I'm giving you, you're going to see what I referred to in a previous module is the ABCs of National Comfort Institute's high performance HVAC contracting. And so there's a handful of links in there that will walk you through the comfort, health, safety, and performance protocol that I mentioned in a previous module. So if you haven't gone through those yet, I would highly suggest that you read those articles online. And then in addition to that, you're going to have what is known as the 17 Steps to Better Duct Systems. That's an article written by a colleague of mine named Allison Bales. He is the resident at energyvanguard.com. Highly suggest that you sign up to get emails from him. He puts out a great newsletter with a lot of great technical information about system performance, home performance, indoor air quality, electrification, decarbonization, the Inflation Reduction Act, and a whole bunch of things that impact our industry and impact the comfort, health, and safety of people in buildings and homes. And then you're going to have another document called Common Duct Problems. Common Duct Problems is going to highlight what are some of the common duct problems that you will see in a home and how to remedy them. And then Ducts Dealing with Airflow and Duct Issues is another document that I believe is from National Comfort Institute that will help you solve some existing situations that you're going to inherit along the way. And then the effects of ducts in the attic. When ductwork is located in the attic, which is a hostile environment because it gets very hot up there during the summer, 95-degree day, it might be 140, 150 in an attic. And so the ductwork being in that situation, you got to take that into consideration. There's an article that kind of talks about that. I have another article called Airflow is Critical and talks about the importance of airflow. Written by the name of, I'm drawing a blank on his name, but it's Ray something or another, and highly educational article. And there's another article called DOE, Duct System Installation and Sealing. And so that's a pamphlet from the Department of Energy about duct sealing, duct systems, installation and sealing, making sure that the customer gets what they're paying for. And again, it's a consumer brochure, so something that you can also share with the customer as well. And then there's also a document that talks about X13 motors. It is also known as an ECM motor, which is electronically commutated motor. But the thing you have to take into consideration, it's not a full variable speed, it's a variable torque motor. And there's a difference between a variable speed and a variable torque motor, which we'll talk about in another module. And then lastly, you're going to have a document in there called Quick Airflow Calculations. And that's a document that I've compiled, which will give you some calculations and some charts and some tables and whatnot that will discuss everything airflow. And then you'll have another document about best practices and principles for installing and redesigning ductwork and some of the things that I've already laid out here in this module thus far. But I'm going to highlight a few of the items that you'll see in those documents as well. So let's kind of go back to the slide content here. And like I said, you'll see where I say see resources. So when you go back through this, again, you can pause the recording because you're going to get access to the recording, and you can, in the class, you have access to the recording, and you can kind of go back and read this content. And the content's not going to be on the quiz, but again, it is something to educate yourself after the class or while you're taking this class right now, this session right now. But properly designed, sized, installed, and tested duct system. That's what it is that you got to do, right? So you don't just go ahead and look at what you're inheriting, right? You have to make sure that it's functioning and that you've tested it and that you're testing in and that you're testing out. And if your company isn't doing that, I highly suggest that the company get indoctrinated into National Comfort Institute protocols. Additional returns, supplies and returns, are they required? More often than not, additional return is going to be required or enlarging a return. Supplies, possibly. If they have some rooms that maybe they turned, let's say, a bedroom into a home office, and now they put computer equipment and a copy machine in there, and maybe the husband and or the wife or dual partners, or maybe they bring in some people to work into the house, and they've turned the house basically into their place of business. Again, that bedroom only has one supply and probably doesn't have a return in many cases. And if it does, it maybe has one. It was never intended to have multiple people, extra lighting, and all that equipment in there giving off all that heat. So again, do you have to do something to improve that situation? I've been in houses where ductwork was tiled over, and they put new flooring over supplies and returns in many cases. And so, do I have to fix something? Don't just go out there and say, okay, I have a duct system. I can unplug the machines and plug in new machines. That's reckless. Enlarge supplies and returns of the main ducts. Do you have to make those things larger? Because again, maybe they were sized for a time yesteryear for equipment that was designed at a different static pressure rating than what is acceptable today. No less than 4 feet supply of a supply plenum. And so if you have a horizontal situation, I recommend that you have a duct that comes off the supply side. That's a main duct that's no less than 4 feet. And then you can run your flexes off of that. Now, ideally, again, I would recommend running a main supply duct all the way down and then have my branches come off, as you saw in the graphic previously. But at the very least, you have to have no less than a 4-foot supply box. Longer is better, and allow that air to get in there and allow for things to come off and transition. Otherwise, you have everything coming off of the 4-foot box. But in some cases, you are limited on space. So you have to take that into consideration as well. Size the return connections for 0.05 static pressure of water column inches, if you will, and that's for noise and static pressure. Again, that's going to be proper based on what you'll find for duct configurations for today, as well as the variable speed motors and variable torque motors that we talk about. Size filters for 300 feet per minute or 0.1 static pressure of water column. And again, a lot of you as comfort advisors are going to have to do this. This is going to be your installers or your project managers are going to have to do this. But again, you're going to inherit some things, and so you're going to change things out. So you can make all of this right at the redesign. Redesign for poor supply and return fittings. We talked about some of that along the way. You'll see more of that in the content that additional resources content that I've shared with you. But again, redesign and fix and replace and upgrade things that you inherit. Straighten, shorten, and support flex, like we talked about with the DS3 straps. The other straps that exist out there, they're kind of a mesh strap. They pinch. What happens is they'll pinch and they create those sags, that slinky effect, and that's not good, number one. Number two is if the if the flex is running and then all of a sudden I have to turn it down and I support it with flex, what'll happen is it'll pinch that flex and choke off the airflow because the flex is coming across and the strap is holding up all the weight, especially a bigger flex. And you'll see it basically shrinks that the size of the ductwork. So effectively you would have to enlarge the return to get the same airflow. Oversized supply takeoffs or transition to connected branch ducts, meaning it doesn't make sense to just go with a round duct tapped into the side. So you want a takeoff to be oversized a little bit, if you will, so or use a transition boot to come off of that, transition fitting to come off of that to go into the branches, versus just tapping collars straight into the side. Duct tightness and sealing. You're going to inherit a duct system that's going to be leaky. I guarantee you, if you just walk around and you should crawl the entire duct system in the basement, the attic, or the crawl space, or the garage, or wherever it's located, wherever you can access it, go ahead and look at every joint, every seam. I guarantee you will feel leakage there. If you can pull out the theatrical smoke, you can bring it to life and see it, and maybe even video it for a customer and let them see it if they can't travel with you up into the basement, attic, or crawl space. Duct installation and thermal barrier. You're going to, again, inherit ductwork that's probably going to have R2 or R4 insulation on it, number one, on the outside of it. Or it might be flex that's insulated with R2 or R4. again, I'd recommend upgrading that to R8. It's a hostile environment. Odds are it's in, which is the attic in most cases, that you're going to find it insulated ductwork. Ductwork also should be insulated when it runs through any unconditioned space, such as a garage or a crawl space. If it's a heat pump, the ductwork supply and return should both always be insulated, in my opinion. Now, there's some school of thought about duct board. It's an insulated fiberglass board that's rigid. There's some thoughts on that, and again, it can function as ductwork, but would you want to be breathing insulation? And as that ductwork breaks down over time, you're going to find out that a lot of the atmospheric dust in the house is made up of the insulation in and of itself. A lot of the floaters and the sunbeam you'll see is made up of the insulation in and of itself. And then there's also sheet metal ductwork that was installed years ago that was lined internally as well. Again, I'd recommend getting rid of that because it held on to a lot of dirt. And again, you can't clean insulated ductwork and get it fully clean. You can't clean flex and get it fully clean. So you're better off just replacing that and starting new and then optimizing the ductwork for the new technology anyway. And then giving customer a better designed, installed, sealed, insulated duct system that is up to today's technology and is going to allow them to maximize the performance of the machines, the high efficiency and advanced technology that they're buying. Dampers and zoning, that's something to take into consideration as well. The dampers, okay, there's the doors, a little air, I call them airflow regulators. They're inside the ductwork. Again, they allow you to shut off the airflow at the source. Registers can be closed, they were just never designed or intended to be closed. And so if customers are closing off registers saying, well, we're not using that room, our kid's off at college and we're empty nesters and we want to direct more airflow. Well, their thought is right, but the problem, if you will, the intention is right, but the execution is flawed. And the reason is because the air has made the trip down the pipe and all of a sudden it hits the register in the room, and now the air is turbulating back all the way back to the main duct, and then it creates turbulence inside the ductwork. It's like a traffic jam at the bottom of the off-ramp, right? And now all the traffic on the off-ramp backs up onto the highway, and now we have all the cars now backing up onto the highway, creating now traffic for the through traffic that wants to go through. Ideally, you would want to shut off that exit and make everybody else go down to the next exit. And then that way it keeps, traffic flowing and no more problems, and everybody who needs to exit exits, and they get out a little bit later, right? And so the idea is the same when it comes to airflow. Shut off the airflow at the source in the main duct where it branches off into the branch, and that will allow you to basically regulate that airflow. And that way I can also fine tune the system. So for example, I might put in a 6-inch supply and I might feed a bathroom, but that 6-inch supply and all that air is not needed in the bathroom, so I can damper that down, and that way I can direct more airflow to where I need to. And then zoning, if you have a zoning system, which is automatic dampers within the duct system, again, you got to make sure that you design the duct system for the zoning system. And again, that's a little bit more advanced, and I will leave that up to you and your team to kind of study up on zoning and designing duct systems for zoning, as well as, again, I would direct you back to National Comfort Institute on that. And then lastly, we have what is known as grills, registers, and diffusers. So grills are return grills. They're just stamped face. They have no ability to direct the air, and they allow the air to kind of, again, we use those for returns. We allow and they should only be used for returns, but you will sometimes see them as supplies. But we allow those to pull in the air. And I like to use commercial grade grills nowadays because they're less restrictive and they allow that air to flow a little bit more freely especially with these high efficiency, advanced technology, variable speed fans. And so I'd rather change out the ones that they have there. And if I'm putting in new, I'm going to put in new commercial grade grills that have wider spacing between the louvers. And then registers and diffusers. Registers can be a floor register, a sidewall register. You may see a sidewall register in a ceiling. Don't recommend it, but again, you'll see it done. And then they make square and round ceiling diffusers. You will see the diffusers more so in a commercial application, but again, there are some in residential as well, and those are better for airflow as well because they distribute the air. Like I said to you a little bit earlier, registers are not designed to be closed. You can fine tune them a little bit to direct the airflow off the occupants because you never want to blow air on the people themselves, and you'll see that in one of the documents that I shared with you, 17 ways to improve duct systems. But those registers also could be noisy. And again, when you make them less restrictive, they become less noisy. But the idea behind a register is it's designed to throw the air. Okay, it's either throwing the air across the room from the sidewall, from the floor up and out, or from the ceiling, as a curtain is kind of coming out of the ceiling and kind of showering, if you will, over the people, without hopefully blowing onto the people. So, look at where when you go into a house, where are you seeing the supply registers and diffusers, and then where you also seeing the return grills. You don't want them blocked by furniture, and so you got to make sure they're in a good location and there's an adequate number of them and they're properly sized and designed. Also take into consideration the fact that you may have some heating-only registers, and those are registers that have a stamped face, they have a single lever in the center, and they have a little flapper on the back. It's not a louver, okay, that's going to allow that air to be directed up and down and thrown side to side with the front louver and the back louver combination. It has a single flapper in the back. That's a heating-only register. And you may inherit them on houses that have air conditioner, but I would change all of those out. And you will find those in older areas of the country, especially in cities. So that's airflow in a nutshell. Again, I'm going to invite you to look at the additional educational resources and get a good depth and breadth of knowledge and read everything that you can when it comes to airflow, because again, you can get great equipment and you can install it, but if you can't get the air to where it needs to get to and get it back, and the system can't breathe the way that it needs to, it's not going to perform. And performance is the product. That's what the customer's paying for. So again, it begins and ends with airflow, because if we don't have the right airflow, we can't heat and cool. We can't clean the air. We can't purify the air. We can't humidify and dehumidify the air. We got to get the airflow proper. So it all starts with airflow.
Awesome content right there from Drew Cameron, as always. Now listen, if you like this content, please share it with your friends via Facebook. If you're not a member, go ahead and click the button below to get a free 30-day trial of our entire Contractor University platform. There's an awful lot there and you'll get it for free. We'll see you next time, folks. Until then, bye-bye for now.